By 2027, around 7,000 small satellites are expected to be launched, with constellations accounting for around 80% of the future demand in units. As small satellites get cheaper and easier to launch, more commercial companies and smaller government agencies are beginning to launch their own constellations. This is alongside the larger agency missions that continue to collect huge volumes of data. We are already seeing a huge growth in the volume of data available from Earth observation satellites, which will only increase exponentially in future. Cloud computing and machine learning will be essential to unlocking the information contained within this exponentially growing collection of data.
ARD means analysis-ready data, obviously, and it means having a series of measurements from satellite instruments that are actually ready to use so that scientists who are not necessarily specialists in remote sensing can actually pick the data up and use it easily.
Countries and international organisations have expressed a desire for support from the Committee on Earth Observation Satellites, known as CEOS, regarding ARD products. In particular, to facilitate access and processing of satellite data into CEOS analysis-ready data for land products, known as Card4L products.
One of the first and the main action we did to give a definition to Card4L, as the general term ARD is used all over and in any kind of scope. We also created the so-called product family specifications document, where we further defined at what level such data should be processed to be able to be called Card4L and to be able to put the CEOS logo in there.
The product family specifications provide two levels that the data can be processed at. The threshold level is the minimum requirement for the data to be called CEOS ARD, while the higher target level is an aspirational goal for data processing. However, it is not intended to be met in the near term. After a data provider has completed the self-assessment of where they think their data sits, the CEOS Working Group on Calibration and Validation gives a final peer assessment to determine whether the data meets the card requirements. The Landsat missions have been continually observing the Earth since 1972, and recently the United States Geological Survey has begun processing this data into Card4L.
Since opening the Landsat archive in 2008, the USGS has made millions of images freely available to users around the world. In late 2020, the USGS greatly expanded access to this archive by making Landsat products available globally through a public cloud environment. At the same time, the USGS reprocessed the entire Landsat archive to introduce Level 2 surface reflectance and surface temperature analysis-ready data as standard products, which became the first ever products to be endorsed as Card4L through a comprehensive USGS self-assessment followed by a CEOS WGCB peer review process. Additionally, these products utilized Europe's Copernicus Sentinel-2 Global Reference Image, or GRI, to geometrically align data from both missions to greatly enhance interoperability.
Another example of where ARD is useful is in the radar community.
We've had spaceborne radar missions in orbit for 30 years now, but the user community has until very recently been very small and expert-oriented. And many users now, they realize the great potential of spaceborne radar, but they lack the expertise and or the processing tools. And this is where the CEOS analysis-ready data comes into play. And we currently have specifications for 2 ARD products endorsed by LSI-VC, and we have more in the making.
The Digital Earth Africa project sees analysis-ready data become available for many non-specialist users across the African continent.
What's happening with Digital Earth Africa is that for the second largest continent on Earth, we've pulled together the full time series of Landsat and Sentinel-2 data and Sentinel-1 data in a format that's indexed into a data cube and can be used by over 1,000 users of that environment, none of whom have to be specialists in the data. And none of it will be feasible were the data not being provided as analysis-ready data. And as the private sector starts to provide analysis-ready data, also it will be more and more feasible to integrate multiple data sets into these large frameworks.
If we talk about Card4L until now, which is of course refers to land, our next natural step to go beyond land. Here we first looked at the other large domain, aquatic and ocean.
The LSI-VC partnered with the Sea Surface Temperature Virtual Constellation to make this happen.
CR's ARD framework and process is a pathway for well-known and well-fitted ocean remote sensing products, including sea surface temperature data sets, to be utilized even more broadly. So specifically, the role and connection among sea surface temperature, the ocean chlorophyll, salinity, ocean wind, sea level, ocean mass, and the air sea indicators is made more accessible through ARDs. And for sea surface temperature, especially being a key climate indicator, this is an especially relevant goal.
We want to even look beyond not only land, but ocean and aquatic as well. So we are already talking about the atmosphere, for example. I would also like to mention that LSIVC will be starting a new activity, the topic of discrete global grid systems, which is closely connected to the Card4L initiative. We need a system where all these data will fit in.
You can go to the website, ceos.org/ARD, to get all the materials on analysis ready data. So CEOS analysis ready data is a community initiative. We're very keen to see as many people involved as possible, and we've reached out to the private sector and academia and others to be involved in the working groups. It's communities of practice that are really doing that development of the specification and shepherding it forward. So, and we are always looking for new perspectives, feedback, and participants in those forums to help drive the work.